How are solar batteries made? The increasing demand for sustainable energy solutions has driven advancements in solar technology, making it one of the most viable renewable energy sources. Solar batteries play a crucial role in making solar energy more accessible and reliable. These batteries store excess energy generated by solar panels during peak sunlight hours, allowing us to harness solar power even when the sun isn't shining. In this article, we will delve into the fascinating process of how solar batteries are manufactured, shedding light on the components and steps involved in their production. There are many solar battery manufacturing methods and types of solar batteries, and currently the most used ones are monocrystalline silicon and multi-product silicon solar batteries. This solar battery is technically mature, stable, and reliable in performance and has high conversion efficiency. It has been industrialized and mass-produced. In fact, it is a large-area semiconductor PN junction. The upper surface is the light-receiving surface, and the grid electrode made of aluminum-silver material is vapor-deposited. The back surface is the bottom electrode made of nickel-tin layer. Both the upper and lower electrodes are welded with silver wires as lead wires. In order to reduce the reflection of the incident light on the surface of the silicon wafer, an anti-reflection film of silicon dioxide or other materials is evaporated on the surface of the cell. The general method of single-crystal silicon solar battery manufacturing is briefly described below. Selection of silicon wafers. Silicon wafer is the basic material for manufacturing single-product silicon solar cells, which can be cut from monocrystalline silicon rods with high purity. When selecting a silicon wafer, the conductivity type, resistivity, crystal orientation, dislocation, and lifetime of the silicon material should be considered. Sliced silicon wafers with dirty and uneven surfaces. Therefore, before solar battery manufacturing, surface preparation is performed. Surface preparation is generally divided into 3 steps. Use hot concentrated sulfuric acid for preliminary chemical cleaning. Corrosion of silicon wafers in acidic or alkaline etching solution. Use aqua regia or other cleaning solution for chemical cleaning. After chemical cleaning and etching, the wafers are rinsed with high-purity deionized water. Diffusion junction. The PN junction is the core part of single-crystal silicon solar cells. Without the PN junction, photocurrent cannot be generated, so it is not called a solar cell. Therefore, the fabrication of the PN junction is the most important process. High-temperature diffusion method is usually used to make the junction. Taking the diffusion of phosphorus on a P-type silicon wafer as an example, the main diffusion steps are the preparation of diffusion source. Dissolve ultra-pure phosphorus pentoxide in an appropriate amount of ethanol or deionized water. Shake well and then dilute. 2 source. Take out the surface-prepared silicon wafer from deionized water. Dry the coating source under infrared light to make it evenly dispersed on the silicon surface, and then dry it slightly with infrared light. Then put the silicon wafer into the quartz boat. Then, push the quartz boat with silicon wafers into the quartz tube in the furnace. Take out the silicon wafer, and the junction process is completed. Remove the vinyl, wash and dry the silicon wafer for later use. Fabrication of upper and lower electrodes. In order to output the electric energy obtained by the battery conversion, 2 electrodes, positive and negative, must be made on the battery. The electrode on the light side of the battery is called the upper electrode. The electrode on the back of the battery is called the lower electrode. The upper electrode is usually made into a grid line, which is conducive to the collection of the generated current and enables the battery to have a larger light-receiving area. The lower electrode is all over the back of the battery to reduce the series resistance of the battery. When making electrodes, place the silicon wafer in the bell jar of the vacuum coating machine. When the vacuum degree is high enough an aluminum film will condense on the surface of the silicon wafer, and its thickness can be controlled at 30-100 mm. In order to facilitate the assembly of the battery, a layer of tin aluminum silver alloy solder needs to be brazed on the electrodes. In addition, in order to obtain a grid-shaped upper electrode, a metal mask of a certain shape needs to be placed on the silicon surface when aluminum and silver are evaporated. The grid line density of the upper electrode is generally 4 lines per square centimeter, up to 10-19 lines per square centimeter, and up to 60 lines per square centimeter. During the diffusion process, a diffusion layer is also formed on the surrounding surface of the silicon wafer, which is usually removed when the back junction is etched, so this process can be omitted. If the perimeter of the cell has metal sticking to it during brazing, it will still need to be corroded to remove the metal. This process has a great impact on the performance of the battery because any small partial short circuit will make the battery bad and even make it waste. The method of etching the surrounding is relatively simple, as long as the 2 sides of the silicon wafer are coated with black glue or masked by other methods, and then put into the etching solution to corrode for 30s or 1 minute. Inspection and testing batteries produced through the above processes must be tested before being put into storage as finished batteries to check whether their quality is qualified. The main test in production is the volt-ampere characteristic curve of the battery. From this curve, parameters such as short circuit current, open circuit voltage, maximum output power, and series resistance of the battery can be known. Encapsulation of monocrystalline silicon solar battery modules. In actual use, monolithic solar cells should be connected in series and parallel, sealed in a transparent casing and assembled into a solar cell module. This sealed assembly prevents atmospheric corrosion and extends battery life. The modules are connected in series and parallel to form a solar cell array with a certain output power. At present, some factories also adopt other processes according to their actual conditions, but they are all similar. In order to further reduce the cost of solar cells, many factories have recently adopted many new processes and technologies for making solar cells. For example, selective corrosion is used on the surface of the battery to reduce the surface reflectivity. Screen printing, electroless nickel plating or silver paste, sintering process, is used to prepare the upper and lower electrodes. The anti-reflection film is deposited by spraying method, and then on the solar cell. All of these can greatly reduce the process cost of solar cells and greatly increase the yield. Other new processes such as ion implantation, laser annealing, laser doping, and molecular beam epitaxy have also been applied to varying degrees. Throughout the production process, stringent quality control measures are applied to ensure that solar batteries meet industry standards. Testing includes verifying capacity, performance, efficiency, and safety features to provide reliable and durable products. The manufacturing of solar batteries incorporates complex processes, advanced materials, and cutting-edge technology to create efficient and sustainable energy storage solutions. As the global shift towards renewable energy sources continues, ongoing research and development in solar battery production will further enhance efficiency, reduce costs, and accelerate the transition to clean energy. Utilizing solar batteries is not only an environmental responsibility, but also a crucial step towards a greener and more sustainable future. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.